Hi guys, hope you good since last video. So, the introduction is going to be around 2 minutes. What I want to do from now on is focus a bit on LangGraph and LangChain and put those videos in a playlist. The purpose is to be able to rely on only LangChain and LangGraph to build your custom business logic. Therefore, enjoy implementing AI in your projects and automations. This video will have the core concepts to understand LangGraph and how it works basically. We will run some easy queries and use a dummy LLM tool, example coming from the LangGraph documentation. In next videos, we will focus on different parts, step by step build a nice graph, which will introduce some questions for the future and hope will help you to think about it. I've been using Query a lot as it is very convenient and easy to understand, but as you can see, every 3 days or a week there is something new in the AI sphere, updates, change of paradigm that you can't really follow. So this have brought to me the idea that it is better to have minimal dependencies and stick to one framework, and if needed, adding those query libraries as side agents, but if they change too much or become too complicated, we still know how to make it custom. Please like and subscribe throughout those videos. Some will be long and some are shorter. And use the comment section to talk to each other about your ideas and help each other. So the LangGraph concept overview. So we're going to go through the component that you need to know. Nodes, different nodes, there are functions attached to those nodes. They're going to process, retrieve document, LLM call, can be also a tool node. To connect those nodes, we need different routes, edges, that's how they call it. So just see it as a route, and there is a decision, normal edge from one node to another, or there is also conditional edge, which depend on certain condition is going to take one route or another. So we've seen the nodes, we've seen the edges to connect those. You have the LLMs that you already know. So you will need this component called the LLMs. The tools or the helper functions, encryption, data formatting, API, call, any tool that you want to use. And here the persistence, the states, messages, states, that's the one will be probably using the most because it comes from the LangGraph library, but you can also build your own custom ones. So LLMs, nodes, tools, edges, and those states, everything is going to be combined to create this runnable by compiling it in the LangChain runnable. And we use different functions, depends on what you want to do. Invoke, stream, or batch. If you use the invoke function, it's a synchronous call, single input, single output. You start the graph and you wait for the end output. If you use the stream one, it's asynchronous, streaming output. So you see the output at every step. So you can use a for loop for that. For the batch, it's a parallel processing, multiple inputs running in parallel, and you get a list of outputs. It's good to compare. You put 1,000 inputs, you get 1,000 outputs, and you see how you're going to improve your system. So it's a good way to test. After having seen those components, we can go through an example here of a user. The user goes, send his query. The first node is a retrieval node, try to retrieve. After we arrive to a conditional edge, Here there will be a function decide to generate or search in internet. So depending on if it has retrieved or not. If it hasn't retrieved any response, it's going to go and search through the internet to answer to user query using the web search node, or it's going to generate an answer directly if it has found the answer using the generate node, and provide the response to the user. Okay. So this is how you're going to form your little graph. You can go also through the prompting flow. There's a prompt. You can create your templates. So you'll see in the future I'll be creating my custom templates with the input variables which are going to be injected into the prompt. So the type of action, the prompt, we pipe it to the LLM. We pipe it to a parser if you need any function to parse the output. In this example, we have the first input is a user query, for example. Second input is a function output, for example. The response, type of action, the one that we used before. And we use the invoke function with a dictionary of those inputs, variables that are going to be injected to the prompt. So this is the format of a prompting. Using the invoke here, what we're gonna get a single input and single output. We just wait for the graph to run and finish its job. After, we can also see the flow, the LangGraph flow in terms of nodes and edges. So we have a workflow. We add the nodes. This is a retrieval node. You have a grade document node, so you put the name first, and after you put the function that is going to be associated to that node. So each node have a function associated to it to process its job. All the nodes are used to make a workflow. So you start the root. You can use this keyword start. There is also another way to do that. So it's going to start, go to the retrieve node. Those are the edges, the roots. So from retrieve, it's going to go to the node grade document using that edge. So edge here, you see the root, then processing. Normal edge. There is also conditional edge. We're going to see the conditional edge after the normal one here, from one node to another. Here, add conditional edges. It's like a if-else, which will route depending on the output function to different nodes. So from the grade documents node, so from this node here, we want this conditional edge to start from this node and decide to generate is a function. Depending on the function output, the function can output search or can output generate. If the function outputs search, we use the web search node. So we put the name of the web search node and it knows that it has to go to this node. Generate, if it outputs generate, we go to the generate node in the same way. So the generate node with the generate function associated to it. If else possible routes, so after that conditional edge, we need to provide the next routes, the next ways, next road to follow. So from the web search here, when it ends, we want it to generate a response. And if it has found a document, for example, we need it to generate the response straight away without going to the internet search and end. So this is translated in this graph, almost the same as the one that we've seen before, with the conditional edge here. But this helps to understand it better. Output, search, web search. Output equal to generate, we go to generate. We end it, and the user gets his response. Okay. So that's why when you're using LangGraph, the best is to draw first. We have a little break here, and we're gonna talk about the grass project that I've talked to you before. So this is the code in red if you want to use it, but just about the referrals, steps. If your friend invite another friend and so on, so it's a 20%, 10%, 5%. And they also introduced the wallet, Solana wallet. So this project is going into the right direction. Let's go to the introduction of LangGraph. So this is a very important part to understand how you're going to build your logic. So highlighted here are the helper functions. So those are the functions which are going to be used by the different nodes on the conditional edges. So here you have the search tool, which is using the decorator tool. It's a dummy tool, but we're going to use it just to get this simulation of using a SUF internet search tool. So if you use the San Francisco or SF, it's going to be returning 60 degrees. Otherwise, it's going to be returning 90 degrees. So the tools, we put it in the list. Search here has to be put in a list. On the list, you can put it in a tool node. We create a node, and we put the tools, we bind those tools to that node. So whenever this node is called, this function is going to be used, which is a LangGraph pre-built. After here, we have the model. We're going to use the Grok model, and we're going to bind the tools. So the tool list can have several tools. If you put more than one tool, the LLM is going to read the doc strings or the different instruction in order to know which tool to use. So it might use the tool if it needs to use it or not use it. After you need to set up the using chat Grok. Here I'm using Grok, for example. Temperature, the API key, and the model name. So the tokens, if you want, you put whatever you need to put as a variable. We have another helper function. This will be used by the conditional edge, where we're gonna instantiate the states, message state. So I'm just going back to here, so you can see it's part of the components. I showed you there's one here, which is the tools. So we show the tool, and here you have the states. So here we put the message state, we get all the messages. On -1, we get the last message in the list. If this message has a tool call, we're going to return tools. Otherwise, we're going to return end. So tools is the name of the node. I'm going to show you the nodes just after. Call model. So this is for the agent node function, which is going to also be using the message state. Get all the messages, and at the end return the response. This is a way to extend the messages list from the state. So returning the dictionary message and putting the response in a list. So the model is going to be using the model with the tools, using the messages. So from one node to another, you have a return message, and it's going to be incremental. and depending on how many tokens you can send, you're going to get the last messages sent. We instantiate the graph here with this workflow variable with the message state put in it. And after we add the workflow add node agents, we add the agent node and we link to it the call model function, which is the one which is going to be processed on that node. And for the tool node, we have the tool node function that we have created here. After here, we can use set entry point for the workflow, for the graph to start at the agent node. Here in this example, I've showed you that you can use start. You can see here start retrieve at the edge, or you can use set entry point. And you just put the entry point where it's going to start. So it's going to start at the agent. After that, straight away, we're going to have a conditional edge starting from the agent. This conditional edge is going to use the should continue function. The should continue function, which is going to get the messages and use it to decide if we answer the user or if we use the tools. After we need to add the tools, this one. So here in this example, decide to generate. So there is different ways to do it, or you put in the function, the logic, or you can capture it here in the conditional edge in a dictionary. At the edge. So when the agent in this conditional edge uses the should continue function, it's going to go to the tool. And the tool needs to return its answer to the agent so that the agent can answer to the user. So after the conditional edge, you need to decide what route is created. Checkpointer is a memory saver. So this one here, it's optional, but if you want to add a memory into your graph, so persist state between graph runs. And here we're going to compile. And we're going to add this checkpointer, which is the memory. And we're going to put that in the app variable. So the checkpointer, for example, here I put a thread ID. If you had a workflow where you want to stop the graph and restart it after, you can use this thread ID to restart the graph at its state, and the state in which it has stopped. So here we have we're using invoke, and we're using a query, human query, which is going to be having the San Francisco, the SF keyword. So it's going to be returning 60 degree in this case. And the model is going to be invoking these messages using the tool. And after at the end, we can capture only the message content. But I will be showing you the full returned object that we're gonna be just looking at the details of it. So I'm gonna copy this and put it in a test file just to run it. Let's copy this and run the graph. Just gonna fix some stuff really quickly. Okay. Okay, so now we have it here. We can run it. Yes, we can run it. So it's a test.py. We wait a few seconds and we see what's going to be the answer. Okay, so we got an error here. Let me just fix this quickly. I'm gonna import the right model. That's the one I want. And let's run it again. Okay, so I'm missing one import. Let's put the import. Import literal. Well, it should be fine now. So this is also to show you that you need to be patient. You're gonna get some errors and you need just to fix those. So here we can't pass it as a JSON. So I want it to have a nice output, but we can't. So let's just get rid of the JSON dumps and run it again. It should be fine now. So we had SF in the query. So it should return 60 degrees in the answer. So this is the full output of just to see the object. We're gonna get this object. And let's see how it looks in details. Response object checking. So let's just check this. Fast forward this part. That's how I want it to look. Just in the JSON dump. It didn't work. So that's all you're gonna get from it. The human message, that's the one that we sent initially. Okay, so this is good. So human message. What is the weather in SF? That's what we used here in the message. So when you invoke, you need to invoke with a message. You need to write a message at the beginning, otherwise you're going to get an error. Here the AI message is a tool call. The query, current weather in San Francisco. The name search, this is the name of the tool, which has been called. Search, so the LLM has used the tool. So if there is tool call, it's going to use the tool. It's going to go to the tool node. After you get the, here it says type function. So this is a schema for tool calling. Here we get the response metadata. So this is good when you want to do some calculations, or if you want to have a dashboard with some different calculations made. The model name, YAMA 370B, tool call. And here it says which function has been called, what was the query. And this is the tool message, which is the answer. 60 degrees. So 60 degrees and foggy. The weather in San Francisco is 60 degrees and foggy, and this is the full answer. So the tool answer, and after the LLM has just formatted the answer. It's 60 degrees and foggy. That's good. So we've seen this, how it is formatted. I can just comment it out, and we're going to print only the contents of the answer. So it's messages, we get the last message and content. Here I put Tokyo instead. So we're expecting to get 90 degrees, which is the other answer, as it is not San Francisco. We're going to use this simple example and do some different queries in different ways for you just to understand what's the mechanic behind it. What did I do again? Name tool messages. I need just to comment this part out, because otherwise it's not going to run properly. So let's just comment this out. Let's run it again. It's 90 degrees and sunny. That's what we were expecting. If there is San Francisco, it's 60 degrees. If there is not San Francisco in the query, it will be 90 degrees. So visualization of graph representation. So there is also a little code snippet in order to get the graph representation. The drawing of it automatically done by the IPython library. So we just get the graph drawn here. Start goes to the agent calls the tool answers to the agent, and it goes to the end. So here you can see the different edges and the conditional edges and everything, the nodes. So the entry point is the agent. After we have the conditional edge, starting at the agent, should continue or not. Should continue, it's going to call the tool. And after that, the tool is going to answer to the agent using this edge, this route. Start, agent tool answer to the agent, agent answer to the user at the end. And that's why you can use those start and end keywords in capital letters. It's good to have the graph represented like that so that you can modify it and fix it. Change conditional edge output capture. So we're going to play with it a bit, because here there's only the function, but here I've shown you the example showing the output in this way. So let's just transfer this in the other side in our code so that you understand that you can do it this way as well. I prefer this way. I prefer with the dictionary. So I don't need to go to the function to remember what it outputs or does. So here let's say it returns tools. If the function returns tools, we're going to go to the tools node. If the function returns end, we're going to answer to the user. So returns tool or returns end. maybe I'm gonna change. Let's change this here so that we know that it's output from the conditional edge. Here we're gonna put just a variable. A string, no tools. So tools and no tools. So if it returns no tools, we end the graph. Okay, let's run it again. So let me check and change here. Just put SF, San Francisco. So we want to see the 60 degrees. And we're using the tool. So San Francisco, 60 degrees and foggy. That's what we got. That's good. And let's change for Sapporo. So we should get the other answer here, as the conditional edge says end. Using this search function. Sapporo, the weather is 90 degrees and sunny. That's good. That's what we got when we don't have San Francisco written in the returned tool answer. Imports needed. So here there are a few imports, but actually you need a little bit more. You need the tools. You need all the typing imports if you're using different, if you're using your function with the typing hints. So here we need to load the environment variables, auth for the system. We need all the LangGraph, checkpoint, memory, edges. So here state graph. We need chat grok. And we need IPython to display the image. So here is the full code. Okay, and down there we have that. So how to calculate the cost? So here we just checked before. We got those prompt tokens, completion tokens, and total tokens. You can use the example of GPT-4 4.0 from OpenAI. You can see here $5 1 million token, $15 for 1 million token output and input. So the output, input, and after here we just put the numbers that we have. Okay, so for the completion token, this is the output one, and the prompt token, this is the input one. The prompt that we sent and the completion that we received. Alright, I hope that you like this video. I know it's a bit long, but you need to review this video and try it. Try the different examples that I showed. Play with it. Change the name of the variables. Make sure it works, so that after you will be able to follow along in an easy way, because you got all the basis and you tried yourself. So in the next videos, we're going to be building step by step a more elaborated graph. I'm going to go through different concepts using short videos. And for the long videos, we're going to keep building our graph and showing the different output that we get. Alright, I hope that you like this video. Please like and subscribe, and see you next time.